All right, back again. This one we're going to look at comparing two different Blinky ESCs to see if we can measure any difference in performance between them. So we're going to do this test in using two dynos. We're going to use the chassis dyno, and we're going to use the motor dyno. So advantage of using a motor dyno is there's a lot less variables when you're switching setups and so on, because all you're doing is attaching a flywheel to the end of the motor, and away you go. Whereas with the chassis dyno, the strap tension and alignment and all those sort of things probably have some sort of an effect. So we want to see what happens. Now we've done this testing with identical setups between the two of them, and both of these ESCs are quality ESCs. So what I've got here is the two ESCs I tested was an R1 Digital 200 amp and a Hobby Wing Z-Run V3.1 120 amp. So because there's a difference in the amperage here, you might think that there would be a difference in performance, but that doesn't appear to be the case, likely because the only time you would run into any sort of issues with the current limit would be at the bottom end of the range at startup, where the motor I'm testing here is a 21.5, so it never really gets up to those sort of levels of current, so you're not going to see any difference as a result of that. This will just be purely the performance. So on the motor dyno, you can see here identical. Within measurement error, there's no way you could distinguish between these two. They are basically 100% identical. RPM versus time, drum RPM again identical. There are two lines there, but they are overlaid, one right on top of the other. So let's see what happens on the chassis dyno. The chassis dyno, essentially the same result. There's a little bit of variation here, but not enough that you could really say one is better than the other. They are going to provide equal performance in blinking mode. Same on the RPM versus time. You're not seeing any difference. The curves are overlaid one upon the other. So at the end of this little testing series, what have we learned? Well, in the timing and gearing one, the optimum timing with all the motor testing that I've done looks to be in the 45 to 50 degree range. That's the actual timing on the motor, not necessarily what it says on the can. Gearing, you want to maximize your gearing for whatever timing setting you have until you get into motor temperature issues. Now, I'll just say this on motor temperatures, you may not always want to run the motor as hot as you can possibly get it without affecting your rotor magnetism material. The reason being because you get quite a bit of loss in performance due to the increased resistance of the stator. So most of the time I like to see my motors come off the track around 145 to 155 Fahrenheit maximum. Any more than that and you really start to notice the performance dropping off at the end of the run. Battery, maximize your milliamp hours as much as you can get within the weight limit, and also lowest internal resistance. How that relates to C rating, it should be the higher the C rating, the lower the internal resistance. Would be nice if more battery manufacturers went back to some way of displaying internal resistance the way they used to with nickel metal hydride batteries, but that doesn't seem to be happening. So as we all know, there's some crazy claims on C ratings, and who knows what's right. ESCs, as far as this test went, two quality comparable ESCs had comparable performance, which is a good thing to see. Really need to do some more testing on ESCs that are Blinky only, but I don't have an unlimited supply of ESCs. So if anybody wants to send me a whole bunch of ESCs and a whole bunch of batteries and a whole bunch of motors, I can do a whole bunch of testing, but I don't think that'll happen. Anyways, next one I want to do is I want to use some of this data to validate or show how the simulation in RC Crew Chief can be validated against this test data. So stay tuned.